All right, so just going back to where we were in this part here. My links didn't seem to work, so I'm actually going to jump out of that and we're going to go into the SCASA website right now. So you need to make sure that you've logged in. So I have logged in and straight away it comes up with useful links. So we're going to go to the K to 10 judging standards and materials. If you're not sure where they are, you go to kindergarten to year 10 up the top here. And then we go to assessing and we go down here to the judging standards. Okay, so we're going to go to year 7 and we'll have a quick look at that. And then we're going to do what I've done before is have a look at the scope and sequence between them. So technologies. Okay, and design and technologies. So we're going to go to the assessment pointers. All right, so I'm going to just zoom this in a bit so that you can see it. Okay, so you can see that for us to actually assess a student, we need to assess all of these aspects and only one of these ones. So let's have a look at the technology and society. So let's have a look at the C grade in particular. The student needs to outline ways in which products, services, and environments evolve locally, regionally, and globally. So they need to be able to outline. They need to be able to recognize competing factors in the development of technologies. If they only list, then they can't get further than a D grade because this keyword is important. So in D, they need to be able to list some ways of products, services, recalling few social and ethical and sustainable factors. Here, they have to outline. Here, they have to recognize. So that's the C grade. To go into the B grade students need to describe ways in which products, services, and environments evolve locally. They need to be able to identify competing factors. And then to get your A grade, students need to explain ways in which products, services, and environments evolve locally and identify competing factors in the development of technologies with supporting material examples. You can see the level of sophistication as we move forward from the D to the C to the B to the A. And that's extremely important when you start creating your assessments to ensure that they allow students that are capable to get up to these areas. Same with our context. Let's have a look at materials. Materials identifies how the selection of material and technology processes are influenced. Here, they select material components tools with minimal consideration. So if you are telling them you must use a tenon saw and that's the only type of saw they can use for a particular project, you're not allowing them to select more than anything except one. And it says selects with minimal consideration. So you need to prompt the student. Okay, we have a coping saw here, we have a tenon saw here, etc. What type of saw do you think might be useful in this particular project? Get them to select. In C, they have to identify how the selection of material are influenced by the combination of materials. So you might say, okay, we're going to do a cross-halving joint, or do we do a finger joint? Why would we do one over the other? They need to identify why one is being done and not the other one. Describes and explains is the A. So you can see again that level of knowledge developing. In regards to the design process, again, let's have a look at the C grade, which is this one, the middle one here. Outlines and identifies the purpose. Here they describe the purpose, and here they outlines and efficiently defines the purpose. Let's go back to the C. Identifies constraints and considers components. Here they still identify the constraints and they list components to consider. And here they describe. C uses a wide range of techniques, appropriate technical terms, and technologies to design, develop, review, and communicate ideas, plans, and processes. So, this is the initial ideas, concept development, and final designs. They need to have an understanding, a few range of techniques. So, they need to be able to do more than just 2D drawing. They need to be able to use possibly computer aided design, 2 point perspective, 1 point perspective, oblique, isometric, a range of techniques, rendering, different types of rendering. So if you're not allowing the students to do that, then that's not basically helping them get further. Here, again, there's not a lot, but here the words are detailed. Okay, so that's a key thing. And here it's comprehensive and detailed. So think about those. Here in C grade, they follow a sequence of steps designed to solve a problem. Here they follows a logical sequence of steps. And here they consider modifications. So they follow the steps that you may have or may have given them. Here, logical, which is one step after another, which I'm sure most of you would have actually organized that anyway. But the consideration here of modifications is the A grade. Right, so then producing and implementing. Apply safe procedures using a range of equipment, components, techniques. Here selects and applies. So here they need to be able to select aspects. And here they need to consistently apply safe operating procedures. Evaluation applies given contextual criteria to independently evaluate. So you can give them the criteria in year 7, if you recall. Applies given to evaluate and provides detailed reflection. So this is minimal, this is detailed, and this is comprehensively. And here again, you need to address this collaborating and managing, and works independently and collaboratively, etc. And here they consistently do that. So that's important to actually look at those aspects. Okay, and I've just gone through those there. Okay, so there is still a lot missing from SCARS for the WA curriculum. And I've got some examples of some assessments that we can actually look at. Okay, so teaching and support material, let's go again to technologies. And you can see there's not a lot there, but we'll have a look at a. So this is a year 1 student looking at food and fibre production, technology society, food and fibre. They're doing quite a bit there. I'll just let's have a look at dance, because there aren't really much in, as we just saw, in technology. So this is dance, and here they have time allocation. This is an assessment. This is their teaching and learning program, week 1 to 2, what we're going to do, week 3 to 4, 5 to 6, etc. I think we can do better than those, and I'll show you as we go forward. There are some Australian curriculum worked samples, so let's have a quick look at those. New South Wales has got quite a bit of information as well. So we have a look at this design project, a LAMP, talks about the learning area achievement. Now, just so that for people, just to clarify something, the Australian curriculum, it teaches in bands like year 7 and 8, 2-year groups, whereas in WA we've broken them apart for a year 7 curriculum and a year 8 curriculum. But there's other jurisdictions that also continue to band, like the Australian curriculum. But it doesn't really matter. I think you can see the difference. So this student is I think they're quite a highly satisfactory. It's talking about, here they've actually found some pictures, and it's talked about it. It's very scaffolded, as you can see. Again, here is some information, fill in the gaps. A little bit more. What must your design do? So the lamp is functional to look nice on the table, etc. some drawings. Um, to me, these are more initial ideas rather than concept developments. It depends on what you want to say. There are no sizes, which does concern me a little bit. And as you can see, they've gone a little bit further. The annotations are actually quite weak. I think we can actually, again, put a few more different annotations there. Here, they've jumped from the concepts, and I can't see, it's probably this one here, but there's no discussion here. So again, I would expect more from a year sevens. There's no sizes, there's no dimensions. So again, lots of gaps in this particular one. You can have a look at the below satisfactory. Let's have a look at this one and compare it. Here, obviously, they're missing stuff. They haven't got that quite correct. Again, very limited type criteria. Sketching is basic, very basic. But again, I don't know about you, but I don't see a big difference between the fail and the above satisfactory. Let's have a look at this one. Okay, so they've got information there. To me, just so that you know, I don't really think that's a very good example, but I guess they're just looking at the timeline there. They've got these right in most cases. They might have a couple wrong. Again, quite limited in their criteria and the sketches and the sketches and the sketches. To me, they are actually all lacking. And if I was going to mark those, I would find it very hard to actually say whether it was an A, B, or C or D, as the case may be. So that's just something to be aware of. There's still not a lot coming out at the moment. We can have a look at some others. The 9 and 10 one, let me just have a quick look from memory. That might have a little bit more um, sustainable house design. I think this is the one that's, so they've created a little video. Let's have a look at the below satisfactory. You can have a look at these yourself and then you'll see. Okay, well, the colors are a bit incorrect, but is it a fail? I'll leave that one up to you. And of course, brainstorming here, an example of above satisfactory one. Let's have a look at this one. Annotations. Let's have a look at the below satisfactory one. It's brief, but it's hard to know with that one unless we delve into it a bit more. Let's have a look at New South Wales. Also has quite a bit of work samples. You need to go here, technology mandatory, and we can view work samples. And here we could have a look at their A. So let's have a look at their A. Um, design brief. Yeah, that looks quite good, but it is an animation, so they're not, it's more digital technologies. Let's go back to year 7 and 8, see what they've got here. Okay, let's have a look at the A's. What have they got here? Oh, okay, let's have a look at the research into materials. And Leslie has done some on wooding and logging. So again, you're going to have a look at these different ones. It's industrial technology here. We're going to have a look at these students. Bracelet design. And here is quite a nice little, it's quite a nice little bracelet actually. And Joe. It is the production though. We don't actually see any of the other information. So it is still in its infancy. So you'll actually find that out, sadly, a little bit. Okay, so there is support materials around, but not as good as we'd like to. So let's have this model spaceship one. Okay, so just going to assessments now, just jumping in a little bit on assessments. It's important to fill in, this is a template that you can actually get from SCASA, and it talks about, what is the year group, what's the area, what's the subject, what is the task that you're doing. And it gets you to really think about what is the content description. Now, the only issue that I have with this is that I like to see the codes, and I'll explain that later. But it is important to know exactly what is being mapped to this particular assessment. And so here they've got instructions, and here they've got a task booklet. As we do, we create a lot of these sorts of things. So what is the design brief? What is a mind map? Do some research, statement of intent, do a PMI. Concept pages, these are initial ideas, could be inspiration, could be whatever you want to call it. They've obviously given some constraints here, maximum area of timber, and again, a little bit of direction and task booklet and reflection. And here at the end, right, this is the technology society. What parts are they doing? Materials, how are they going? And each one, as you can see, is marked out of 5, so that at the end of the day, you are covering every single part of that assessment. We'll jump into assessments a little bit later. Okay, so think about it for a moment. Doing a bit of a snowball here from the teaching and learning strategies. What projects do you think you would like to do for your students? And think about where you're going to pitch it. Is it a year 7? You'll need to look at the year 6 and the year 8 curriculum as well as the year 7. How are you going to pitch the assessments? You need to think about that at the same time. Here are some ideas of different things that you might want to look at. These are all different websites that may give you some ideas about the sorts of projects that you might actually want to get your students to look at. When we see KS3, that says Key Stage 3 and Key Stage 4. Key Stage 3 in the UK is year 6, 7 and 8. 4 is 9 and 10, and then post is further on. So you might want to find some information along those lines that you might look at. Some of the ones I like the Boxwood. I think they've got some great projects. And they come up. Okay, so you could do some laser cutting. These are all laser cutting projects. A CO2 or F1 in cars. There's quite a few wooden coasters, quite a few things there. And it gives you an idea of the different things and projects you can actually do. Let's have a look what other ones are there that you might like to look at. STEM.org, of course, technology and engineering fits into our learning area. And of course, STEM is a big part of that. So again, what do you want to do? Fusion 360, you can actually create your own moving cam tutorial, etc. like that. I'm just going to go through some of these so you can see what they are. This is, to me, the worst designed website ever. However, putting that aside, it's actually quite good. So you could actually look at mechanical toys as something that you might want to look at, and you can go through the automatas and things like that. So they have lots of things here. If you want to learn about graphics, they have all sorts of things. Like I said, it does my head in, the colors that they use. Okay, technology student is another one that a lot of teachers use to go through. So you might want to have a look at materials and design, and they talk about basic workshops and things like that. If you go back home, if we go into graphics, that's actually quite good too. And it talks to you about, isometric drawing, and it's got all sorts of examples and exercises you can do with your students. Blundell's, and you can see a lot of these are UK ones. Okay, we'll leave that one for there. Practical action, love it. It is, I'll go through that one in a minute. I'll show you where that is. That's a really good one. Let's go to designability and find out. Some of these links need to be redone. But here we've got electronics type stuff. Um, aeroplanes, you name it. The eco lamp, very similar to what we were seeing earlier. Um, just really interesting projects. This is one that I've been working on at the moment. Some of you may have done this project, but basically in using a 3D printer, you actually print out the case. So really exciting stuff here. So you can see there is no excuses for creating something that's a bit boring for our students to do. Okay, so the one I wanted to show you was a practical action. So let's go into practical action. Because I think, oops. Oh, okay. We'll jump on that one in a moment. So the components for a teaching and learning program, just so that we're very clear, you need to have a course outline, an assessment outline, student work booklet, theory and planning, assessment tasks, and resources. So what are schools doing? Well, what do we do when we start planning for our teaching program? We need to think about all of those aspects. We don't have textbooks per se that our students get. We use those personally just for us to actually start to develop our projects for the students to do. So here's an example of a teaching and learning program, and you can see that it's year 10 architecture design. It does fit in nicely into the material side of things. So, and you can see here are the WA codes that address those aspects. Um, here's an assessment outline. I've moved on a little bit from this one as well. Now I've asked my students in university to state to me what code each one of these are, because that's important. Here's another example, but it doesn't have the codes. Oh, this one does here a little bit. Assessment outline, this one's better because even though it's got a research task, it's saying to me, these are the codes that I am going to be assessing in this particular assessment. This is digital technologies, just again, an example of the codes though. And like I said, not the best anymore. We've moved on a little bit further from this. I want to see the codes. I want to see where the aspects of the curriculum are being actually addressed. And it is important, I think, that we actually thinking about our students and how they learn and how they can actually demonstrate their knowledge, that we do a range of different types of tasks. Yes, we have a design process portfolio. Yes, we do that. It's required. But looking at year 11 and 12, what is it that students need to be able to do? And so you need to be able to give them design opportunities. You give them production opportunities and you have to give them some response, which could be tests, exams, essays, oral responses, etc. So it is important to have a range to ensure that our students are actually catered for. So there are different types. Again, I grabbed this out of Queensland, different types of assessments that you could be doing. Research, again, oral reports, like I said, we call it response, but it doesn't really matter. They're the same sort of ideas. Collection of work, diagrams, graphs, 3D models, prototyping. We're not all about the finished product. Remember that. It's about the process. Assessment tools that you can use, concept maps, surveys, I do a lot of surveys. I get the students to create a survey in Google Forms or SurveyMonkey, and then they go out and they actually talk to the target audience and get information. We can do all sorts of things to model it. So what's missing? Scope and sequence are general capabilities. I haven't gone through that, but here it is. If you're actually going through here, you can see that. And of course, the cross-curricular links, because don't forget you need to map those into it, into your teacher learning program as well. Some examples of student booklets that you actually might come across.